Chapter 18, Think and Discuss. Got a couple problems here. So number 80, is it possible to wholly convert any amount of mechanical energy into thermal energy, and is it possible to do the reverse? I mean, you can convert relatively easily, not wholly. I would depends on what he exactly means by wholly, but you can convert mechanical into thermal energy. Just take an object, drop it, it's going to hit the ground and stop eventually. That energy goes somewhere. First it starts out as potential, it goes into kinetic, even ignoring air resistance, but when it hits the ground, it will eventually stop, even if it bounces or just thuds. That energy goes somewhere, and that goes into heating up either the ground or the object itself, or both. And so that's mechanical into thermal energy, but going the other way, it's really difficult because you basically need a temperature difference and then some device that's basically going to bleed energy off as the particles move from one to the other. And he comments in the solutions, in the book solutions, that that's not efficient at all. You lose more than half of the energy there. Everybody knows that warm air rises. So as warm air rises, this is the why is it not hotter at the mountaintop? As warm air rises, the adiabatic expansion, basically if I have a bubble of air as it rises, it will expand. As it expands, it's pushing on the environment. So if you think about a bubble rising in water, it pushes on the environment around it. And so it does work. It's taking some of its energy and using it to push. And as it uses its energy, that results in a lower temperature. 85, again, another friend. What response is to a friend who suggests it's twice as hot in St. Petersburg than it is in Boston when the 80 degrees Fahrenheit versus 40 degrees Fahrenheit. Again, that's not an absolute scale. It's almost arbitrary. If they set 0 degrees to be what was 0 degrees Lahoe's and to be 40 degrees Fahrenheit, then you can't make that argument. So it's the argument of 80 being twice 40. Yes, that's true, but when you're talking about temperature, you're dealing with some almost arbitrary scale. So if you do it in terms of an absolute scale, such as Rankine or Kelvin, then it definitely would not be twice as hot. And then 92, classmate says all the stuff talks about perpetual motion. His comment about perpetual motion is that all things are moving forever, as in moving perpetually. And perpetual motion from a physics point of view means that I have a device that will create energy that will feed back into itself, that will keep the machine running. And that's just not the case, because you will always lose energy somewhere. This is the Newton's, keep going back to Newton. It's the second law of thermodynamics. And so you're always going to lose energy. There's no way that you can create a machine that produces all the energy it needs in order to feed itself. Imagine you put a battery into a machine that creates energy that comes back into the battery so that this thing goes on forever. It's just not going to happen, statistically speaking, as is true with almost any thermodynamics thing. You randomly could create this, and it's possible that it could happen. You can't create this. It's possible it could happen, but don't count on it. It just, odds are way against it. You're more apt to win the lottery. So there it is. And continue rejoicing, because, this is physics.